We have been talking in class about how the Earth is made up of different layers. Today we're going to talk about the outermost layer, the Earth's crust. Scientists believe that the Earth's crust is broken up into large chunks called plates, and that these plates are constantly moving over the surface of the Earth at a rate of 2.5 centimeters or 1 inch a year. Over the course of the Earth's 4.6 billion year history, scientists believe that this plate movement has caused the formation of several giant supercontinents, including the most recent one, Pangaea. Scientists believe that the plates are being moved by convection currents within the Earth's mantle. Today, you are going to explore what happens when these different plates interact with each other. What happens along the edges of these plates at their boundaries? To help answer this question, you will be using graham crackers to represent the Earth's crust and orange Cool Whip to represent the Earth's mantle. Now, after taping a piece of wax paper to your desk, spread out the Cool Whip and place two pieces of graham crackers on top. Experiment moving the continental crust plates around and see how you think they might interact. As we discussed in class, after experimenting with the graham crackers and the Cool Whip, there are three main types of plate boundaries. The first one is called divergent boundaries. That's when the two pieces of the two plates diverge or move apart. And as they slowly move apart, you can see that the opening between the two gets filled with magma, which cools and hardens and becomes new crust. The second type of boundary is a convergent boundary. In the case of convergent boundaries, you have two plates moving towards each other and slowly bumping into each other. Now, there's two types of crust that we've been talking about, continental crust and oceanic crust. And in this case, we're going to call this graham cracker continental crust, which is thicker than the oceanic crust, which will be this graham cracker. Oceanic crust is denser and thinner than continental crust. So in a convergent boundary, when they meet up, the oceanic crust slowly gets pushed underneath the continental crust, creating what's called a subduction zone. And in the case of a convergent boundary where you have a subduction zone with the oceanic crust moving underneath the continental crust, you often see volcanoes formed. Now, we just talked about convergent boundaries where you have one continental plate bumping into an oceanic plate. And now we're going to use two graham crackers, both of them representing continental plates. So two plates that have the same thickness and density slowly converging or bumping into each other. I've dipped the ends of both plates or graham crackers into water to soften them up to show you that when this happens, when two continental plates collide, what you have is a slow folding and building up of the plates. Or in other words, where two continental plates converge, you see the creation of mountains. Where the continental crust of the Indian plate and the continental crust of the Eurasian plate converge, you see the creation of the Himalayan mountains. The final type of boundary that we're going to discuss today are transform boundaries. In the case of transform boundaries, you have two plates that are neither diverging apart from each other nor converging towards each other. Instead, they are moving basically side to side. And as they slowly move side to side, pressure builds up, and oftentimes with jolts, the land will move, the plates will move side to side. And in that case, in these types of boundaries, you find earthquakes.